Hi, everyone. Welcome. Thanks for signing on. I can see that it looks like we've had a little bit of leveling off of our numbers arriving. So we're just going to launch right into introductions. Thanks again to many of you who've been joining us for a number of these talks throughout the whole series. Today is our finale talk. For those of you who don't know me and might be joining Greg's talk today as the first one, I'd like to introduce myself. My name is Haley Ross. I work with the Columbia Mountains Institute and I'll be your host today. And you are joining us here for the 6th season of Cred Talks. And as I said, this is our last talk, the 8th talk out of 8. And I'll just tell you a bit about the series. I'll do a little bit of a Zoom orientation, and then I'll introduce our speaker, okay? So again, in this series, we've been hosting 8 scientists. If you're reviewing this talk recording, I encourage you to go to the event webpage, which you can find on CMI's website, cmiae.org, and have a look at the write-ups for the other speakers, and you can find those recordings there too. Greg will be doing a little bit of an overview of what's been presented thus far, but you can delve deeper into the details of each person's talk easily on the event webpage and access those recordings. And collectively, of course, they're going to tell a much bigger and nuanced story. The Cred Talks are financially supported by the Columbia Basin Trust, who gave us some seed money to get this series up and off the ground. Thank you very much to CBT for that support and that continued support as they've been sponsoring the Cred Talks all along. This series is also generously supported by all of you, of course. Genuine thank you for your donations. Without those donations, this series would not be possible. So thank you very much for supporting the production costs of this series. Before we go any further, I would just like to pause for a moment and acknowledge the 4 nations on whose traditional territory I broadcast from here today in Revelstoke, BC. So in the spirit, so that is the Sinixt, the Kootenai, the Secwepemc, and the Silks. And what I was going to say is that in the spirit of reconciliation, I invite you to make an acknowledgement yourself, which is also a handy way of testing out your chat. So if you scroll your mouse down to the bottom of your screen, you'll find a control panel there, and you'll see a little icon that says chat. If you click open your chat, you'll have an opportunity there you could send a message to everyone. You'll see that there's a drop-down menu. Choose everyone, and you can introduce yourself and let us know whose traditional territory you broadcast from today. Thanks, Cora, for starting us off there. As those roll in, I'm just going to move on and take this opportunity to tell you a little bit about the host organization. So as I said, CMI is your host organization, the Columbia Mountains Institute of Applied Ecology. We are a nonprofit organization. We're a society and an association of people working for various fields of ecology, and our home range is southern British Columbia, Canada. But increasingly, we are seeing membership from across BC into Alberta, the Yukon, and the Northwest Territories. One of the main things we do is provide professional development opportunities for ecologists. So those come in many forms, but of course, one of which is webinars such as this. We host a wide variety of courses and also conferences. There are examples of all of those things that I just listed on our website. And for the sake of brevity, I'll just refer you to the website for more information and welcome you to get in touch with me if you have any further questions. All right, so now we'll just get into some nitty-gritty Zoom info there. This webinar, of course, is being recorded. And as I said, you'll be able to find the recording on our event webpage. The video and audio of all our attendees has been disabled for the purposes of this webinar. But if you would like to be unmuted, if you would like us to enable your audio to perhaps ask a more complex question at the end of the talk, you can do that by raising your hand. So again, if you bring your mouse down to the bottom of your screen, you'll see the little raise hand icon. you can click that on, and that will give your hosts and panelists a bit of a notification, and we'll know that you would like to, we'll communicate with you and potentially unmute you as needed. If you've changed your mind or you've clicked that accidentally, or you're done, you can lower your hand. So you just find that same icon, click on it again, and it'll lower your hand. The chat is enabled, as you can see, and that's a really fantastic spot to share resources with one another. That is not the spot where we're going to be handling questions, however. So if you'd like to communicate with one another, share resources, get in touch with the hosts and panelists if you're having any technical issues or need to get our attention for some reason, do so via the chat. Use the drop-down menu to make sure you're directing your message to the people who you would like to receive it. If you would like to ask a question, then we're going to use the Q&A feature. So the Q&A icon is at the bottom of your screen in that same control panel that I've been referencing. Click on that to open it up, and you'll see a little box pop up there, and that's where we're going to direct our questions. So if I could get Pete or somebody in the audience to submit a sample question in there right now, we'll just illustrate how we're going to use this tool. It's been quite handy and working quite well. If you think of a question as Greg is doing his presentation, you're welcome to put it into the Q&A, but we will address questions at the end of the presentation. If you see a question posed in that Q&A that you would like to hear the answer to, you can give it the thumbs up. So can somebody from the audience just put in a, there we go, Peter did it, thanks. He says, what's your favorite color? And so you should be able to see that. There's somebody who has clicked the little thumbs up icon on there, and what that has done is basically given that question a vote. You've said, I'd like to hear the answer to that question as well. You give it a vote, and then at the end, when it comes time to relay the questions to Greg, I will order them in order of popularity and read out the questions with the most upvotes first. Okay, great. Thanks for doing that demo for me. Is there anything else I want to mention? I don't think so. I think that's about it. So now let's move on to the real reason why you're all here today. Thanks for your patience as we move through that. I know that some of you have heard that introduction many times. So I would like to welcome Greg Utzig. He's the man who is, I'd say, unwittingly inspired this year's deep dive into climate disruption after his last year's talk entitled Climate Change and the Biodiversity Crisis. This talk was also recorded in last year's series of the CRED Talks, and I would encourage all of you to go and listen to that talk. It was sort of the precursor to this whole series. And again, it's posted on the event webpage. The link will take you directly to YouTube. Today, Greg will provide a concluding talk to this series, and of course, he'll be adding some insights of his own. Thanks, Greg, for taking it on. That's not in any way an easy task. Okay, so Greg Utzig is a conservation ecologist and land use planning consultant with over 40 years experience in environmental impact assessment, terrain and vegetation mapping, watershed analysis, habitat inventory and modeling, and a wide range of activities related to forest management and biodiversity protection. At present, his focus is on adapting biodiversity conservation measures to the realities of rapid climate change. He has worked with a variety of clients, including government agencies, non-governmental organizations, First Nations of the forestry industry, both in BC and in Southern Africa. Greg has a Master's of Science and maintains his designation as a professional agrologist. Greg has worked on so many projects in our region, you just could hardly believe it. Thank you so much for making the time for this series, Greg, and I'll just pass it over to you.
Hello, presume you can hear me?
Yep, I can hear you.
And I'm gonna take the screen, I guess. Try anyway. There we go. Okay.
Yeah, it looks good.
Looks good. Okay. Thank you very much. As Haley said, we've had a great series of talks previously, and as most people say it's a hard act to follow. The other presentations have been great and covered lots of different aspects of climate disruption. So I'm going to try and sum this up to some extent, but it will be difficult. My opening slide here is kind of a tribute to the Cryosphere, which we had one presentation about, which is the way I began last year on this trip up Grassy Mountain. But the middle of the year is the lower left-hand photo, and that's from my place at Johnson's Landing in the middle of the heat dome. So it was an interesting year. We'll talk about that a bit more. So generally what I'd like to do is do a reflection on the previous speakers, talk a little bit about what did happen last year, and go into some of the mechanisms that create these climate change disasters, and then talk a little bit about what we might be able to do. The previous talks have been a variety of topics, and some of you have seen them all. Some of you maybe haven't seen any of them, but I'll just quickly say Mel Reisner talked about climate itself. Ryan Manonos talked about the cryosphere, particularly about glaciers and what's happening with glaciers in our region. Mike Flanagan talked about wildfire. Janice Brainey talked about what's happening with aquatic ecosystems, particularly at the lower trophic levels. Martin Carver talked about shifting hydrologic regimes, and Colin Mahoney talked about ecosystem changes and non-analog climates and non-analog ecosystems. And Suzanne Simard talked about the need for strengthening forest resilience and some of the ways we might be able to do that. So I'm just going to quickly touch on a few things from each of those. Mel's, he basically laid out the basics of climate change in the southeastern BC. And what he showed was that over the last century, temperatures have been increasing, but over the last part of the last century, they've been increasing at an increasing rate. He also talked about the fact that the frequency distribution of weather, in this particular case, we're looking at temperature, but it's not only shifted to the right, it's gotten warmer, but the change in the shape of the frequency distribution curve is very important, because what it means is we have less normal medium types of weather and much more extreme. And in fact, even though we've shifted into the warmer ones, we're still looking at a significant amount of cold temperatures as well. And he talked about extremes themselves and gave a couple examples. This maximum daily temperature in Nelson, you can see it's completely off the chart, as we say. And he also talked about why. And this is a graph from his presentation, which just talks about the source of these greenhouse gases: coal, oil, gas, and a few other things. And he talked about the implications of some of these changes, particularly the increase in summer temperature and potential minor decrease in summer precipitation. And of course, I think after the last 4 or 5 years, we're all pretty familiar with what the implications of those changes are. And lastly, he talked about what we're doing, or what I should say we're not doing about this, that in fact, if we want to get down to 1.5 or even 2 degrees, we're falling far short in terms of what we've pledged and what we're actually doing. We're still up here somewhere. So I would say that we need to redouble our efforts. And hopefully this series will motivate some people to do a bit more. After that, Ryan Manonos talked about the cryosphere, and he started out by talking the various aspects of the cryosphere. I think living here in the Kootenays and the Columbia Basin, we're certainly familiar with almost all these aspects other than the ocean sea ice. He talked about various ways that we're measuring changes in the cryosphere, particularly glaciers. And he talked about the fact that glaciers are disappearing rapidly. And anybody that's done any mountain hiking here in the Columbia Basin is aware of those changes more than likely. But what he did also note was in the last 10 years, the rate that they've been disappearing is substantially more. In the graph in the upper right, you can see that there was a serious increase in the rate of loss of glaciers. And of course, last year was phenomenally bad. And the map on the right shows the difference in Kootenay Glacier last year in terms of the height of the ice. We're looking at a 4 or 5 meter decrease over much of the glacier and minimum of probably 1.5 or 2 meters everywhere on the glacier, except one tiny little part up here. It's probably a bit of snow drifted in behind Kootenay Peak. He also talked about the fact that the rise in temperature is not the only thing that's taking away our glaciers. It's also black carbon, which comes from forest fires. And last year was particularly bad for that, which probably contributed to this incredible loss. And lastly, he talked about what's projected for the future. And as you can see, there's a variety of emission scenarios here. And we're probably headed on this 4.5. I'll talk about that a bit more, but that's this one down here. And we're looking at by the end of this century, most glaciers are going to be disappearing, given this is where we are today. Next, we moved on to fire itself with Mike Flanagan. He talked about the fact that these increasing temperatures are having dramatic impacts on fire, which I think we saw good examples last summer of that. Drier fuels, more lightning, longer fire seasons, and more extreme weather, which is leading to these huge fires and the drastic loss of forests in BC, which we'll talk about more. This is looking at the 3 really important fire indices, the fire weather indice itself, the initial spread index, and the vapor pressure deficit, which is how intensive the fuels are drying. And you can see that over the last couple decades, we've moved into significant increases in all of those factors. He also talked about the implications of that. These are evacuations due to wildfire since the 1980s. And you can see here in British Columbia, we've had some of the largest evacuations in all of Canada, but they've been spread all the way across Canada. And lastly, he talked about that there's, in addition to fire itself, there's implications of smoke. And I think we had a pretty good example of that last summer. I think everybody is pretty much aware of that. And lastly, he talked about the implications for the future here. These are all the areas we have wildland infrastructure interfaces. So these are all areas that are potentially at risk due to wildfires in the future. He also talked about the fact that these large fires are likely to be increasing, partly because the indices are worse and the fire weather is worse, but as you shift that in things like stronger winds, you shift again this frequency distribution curve and you pick up all these ones out on what was beyond the tail of what was a historical situation. So in this case, this extreme event is 12 times more likely than it would have been without climate change. And lastly, he talked about one of the things that's a mechanism behind these changes, which is a jet stream. And I'm going to talk a bit more in detail about that to show you some examples of what the jet stream, what role the jet stream has played in some of the extreme events we've had over the last few years. And then in addition to that, we had Janice Braining, who talked about implications for aquatic ecosystems. And she talked about 2 mechanisms that are bringing about these changes. One is glacier loss, and the other is fire, which we've just spoke about. So if we just look at what she had to say about fire, it's having direct impacts in terms of nutrients getting into streams. This is from the, actually from the Kelowna fire in 2003. Following that, you can see the influxes of phosphorus from ash washing into streams. So not only is it changing the amount that's going in, but it's also changing the timing, the green being non-burned areas. She also talked about the role of smoke in changing aquatic ecosystems, which I think many people don't think about. And it ends up, of course, here's a couple of examples of without smoke, with smoke. It certainly impedes the input of sunlight, which can change the distribution of ultraviolet rays and the type of light that's getting in, which shifts communities. And in some cases, it's actually been shown to modify fish behaviors. And lastly, I think we're all pretty familiar with what fire does to riparian vegetation. Shade removal obviously has impacts on temperatures, which she talked about. But she also talked about the loss of glaciers and what kind of implications that have. You can see here's a distribution of different types of lakes. these being non-glaciated systems, these being fully glaciated, and these ones being transitional. There's another interesting thing. The speakers talked about the links in Manonos and Mel Reesner and Janice all having worked with each other at some time or other. Well, this particular lake is actually a lake in the Templeton area, which is where I did my thesis work. So we've all got connections one way or another. And she talked about, of course, the loss of glaciers that Brian had talked about and the implications of the loss of those glaciers. Of course, it affects temperature of water, which of course is going to affect ecosystems. And in drastic cases, downstream impacts can be quite severe on fish. This is a difference in glaciated streams versus unglaciated streams and reaching lethal temperatures for salmon. She also talked about the fact that as we lose the cryosphere, we're changing the timing of runoff. And what this means is that you end up with a potential for a mismatch between the photo period, which of course is maximized in June at the solstice, versus having runoff and nutrient input, which used to be aligned with that, and now it's earlier than that. So we end up with this phenological mismatch. And she gave an example of these outbreaks of Didymo in streams, which I think some of you have probably seen in our area. I certainly am familiar with them. She did end on a good note, though, that in these particular studies, she ended up that these Didymo outbreaks didn't seem to be affecting the fish, but certainly other less mobile things like mollusks certainly could be affected, but they weren't studied in this particular instance. And in the next talk, we had Martin Carver talking about changes in hydrology, and he did a lot of talking about the role of extreme in precipitation and temperature and how that is affecting stream flow. This is an example from Duhamel Creek that he gave, where we had here in 2012, we had an extreme discharge in June. It coincided with a high precipitation year and a low temperature versus 2015, which was extreme low, which was very high temperatures and very low precipitation. But of course, in 2021, we ended up with a similar situation again. He also talked about the role of extreme events. This is from 2013. This is the same event that produced $5 billion worth of damage in Calgary, but then it moved on into BC, affected the East Kootenays and the West Kootenays, and resulted in that extreme precipitation in Caslow that Mel Reesner talked about. Martin also talked about the interplay between these various hazards, where interplay between high precipitation and wildfire and hydrophobic soils can result in landslides as well. He also talked about just change in runoff because of the increase in temperatures and change in precipitation patterns, where runoff in the winter and spring are likely to increase because more rain more precipitation is falling as rain than as snow. And also the more rapid snow melt is creating much lower runoff in the summer, and the fall remains pretty well much the same. And this results in changes in hydrographs. Generally speaking, higher winter flows because of the rain rather than snow, earlier snow melt, higher peak flows, but most importantly, lower summer flows, which affects, of course, humans and affects aquatic habitat. He also talked about the fact that rather than increasing our monitoring, giving these changes, what we've been doing is decreasing monitoring. You can see the red over the past few decades, we've completely eliminated government monitoring of small streams, which is where most of us get our water and a lot of the habitat is located. And even overall, we've reduced the number of monitoring stations we have in the Columbia Basin. And lastly, he made the point that we should really be thinking about this one, expect the unexpected. And then Colin Mahoney talked about shifting ecosystems. As an introduction to his talk, which I thought was really quite useful, as he talked about these various emission scenarios, which any of you have looked at implications and outputs from people that are looking at climate change. They're often talking about different emission scenarios, with the 8.5 being called the business as usual, although as Colin pointed out, this is probably not business as usual as we're practicing it today. It's implying an increase in fossil fuels, and we seem to be leveling off. Although with the war these days, who knows what's going to happen. He showed that over the last couple decades, we've moved off the 8.5 and moved on to the 4.5, which in general sounds like a good story, but even 4.5 is not a good story. He talked about the fact that in this case, this is the projections for the Columbia Basin in terms of summer temperatures, and this is the 4.5 here. And as you can see, this is the historic range of variability for summer temperatures. And by 2030, we're going to be out of that for good, even if we reduce our emissions even more. And 2021 was the first taste of what we can expect the future to be. And in fact, the short near-term future, if we continue on 4.5, it's going to be a lot worse than last summer. He also talked about increases in winter temperatures, which are not rising quite as fast as the summer temperatures. But even the changes already, this being this lack of really cold temperatures early in this century, has created the outbreak of mountain pine beetle. And he, in echoing what Mel had to say, was that unfortunately, again, our ambitions of doing something about climate change are falling short, very short. Ideally, we would like to be on this track to get us down to 1.5. And what we're actually on is this track up here. We've made some promises to try and get on these tracks, but Canada, as well as many other countries, are not even living up to their promises. So at this point, we're looking at somewhere between 2.5 and 3 degrees probably. Colin also talked about climate projections for British Columbia or for the Columbia Basin. And he showed this is present distribution of modeled biogeclimatic units. This is the actual climate over the last couple decades. You can see we've already changed the climate, although the full change in ecosystems hasn't been realized yet. He also talked about projections into the 2050s, which continues this same trend, and into the 2080s to 2100, which continues to intensify. And I think some of you have probably noticed, and Colin noted, these probably aren't quite as drastic as some of the projections that I've been using in some of my previous studies. There's a number of reasons for that. Number one, it was older models. And secondly, the newer models tend to be somewhat wetter, although some people question whether that's realistic or not. So I think what we can take away from this is there's a lot of uncertainty in where we're headed going forward. But even these are showing some fairly drastic changes. The other thing that Colin pointed out is that it's not quite that simple. When you look at changes in climate, there's lots of different aspects to climate. There's precipitation, there's a temperature, there's different seasons of temperature. And in this particular case, he took a point here in the East Kootenays and said that some seasons, like the summer maximum, are showing the equivalent climate would have to move up. To find the equivalent climate, species living in this would have to move up here. If we're talking about winter temperature, they'd have to move this high. And if we're talking about minimum summer temperatures, they might have to move this high. But in terms of finding a similar precipitation, they actually have to move downslope. So what it's saying is that it's not quite that simple, that what we're moving into is non-analog climates. This is all the different subzones in the Western US and BC plotted in this three-dimensional climate space. And you can see that if we look at ICHDW, which is located here, if we look ahead 6 or 7 decades, it's not moving to any of these other climate spaces. It's moving out into what we would call a non-analog. And it ends up, when you plot those non-analog changes for British Columbia, it ends up that southeastern BC, lo and behold, is a hotspot for those non-analogs. In other words, we're not heading to somewhere in the States, we're heading to somewhere we don't know and haven't seen before. He also talked about these shifts in extremes, and this is really the unknown. These are projections for maximum temperature for the Columbia Basin under non-climate change. This is as it is today with climate change beginning, and this is where last summer was it's off the charts. It doesn't fit the data. So we really are moving into a new world. And lastly, we had a presentation from Suzanne Simard, who talked about her work in the past. And I think most of you, excuse me, are familiar with that in what's been dubbed the World Wide Web. And this is looking at the relationships between various trees in a stand, each of these little things represented, and their connections through mycorrhizal habitats. She also talked about the need for changing the paradigm of forest management in British Columbia. And I think we're all familiar with what's gone on in the last year in Fairy Creek and other parts of the interior, with people waking up and saying, yes, we do need a new paradigm, and also the growing importance of First Nations and their desire to see a paradigm shift. Suzanne also talked about a project that she's doing looking at climate change in relation to her work on mycorrhizal activity. And these are an experimental program called the Mother Tree Project, where they're looking at different types of forest harvesting, from clear cuts to uncut controls, 60% retention, seed trees, and 30% retention, and across a whole range of environments in British Columbia, going from very dry environments, 9 different climatic regimes, to very wet ones. Also looking at these three replicates of these 5 retention treatments that I explained up here. And so trying to look at a whole variety of habitats and different treatments, and then looking at planting different genotypes with those to see what kind of results we get. And she presented some of the preliminary results, which showed that yes, in fact, if you maintain more trees, you can get lots of positive things. Yeah, you may lose a little bit of growth, but it's offset by lots of other things, including, of course, carbon sequestration, which will become increasingly important. And lastly, she also talked about the fact that these retention can actually reduce fire hazard or fire risk, which is very encouraging given some of the previous talks. So I actually spent the last week or so going through all the talks again, and that was very interesting because having watched them, I thought I had absorbed a lot, but seeing them again, it actually allows you to go back and kind of look at the details. It's amazing how much I didn't get the first time I listened to them. But what I wanted to do was to try and think about what were the common messages that came out of those various presentations. And I think the first one I would say is complexity. As you can see by looking at those presentations as a group, they all were talking about the complexity of the changes that we're talking about. And not only are they multi-scalar, but they're also multidimensional. Secondly, extremes are becoming more intense and more frequent, and they also are extremely important. Lastly, or not lastly, but next, expect the unexpected. Embrace uncertainty. The future we're going into is one you need to grab your hat and hold on tight. And that we're moving into a non-analog future. We can learn from the past, but it's not a useful predictor for the future. Increasing resiliency is going to become an essential part of our adaptation. Experimentation and monitoring are going to be important. We need to start looking at maximizing the diversity of our management to try and learn and figure out what actually will work in this new environment. And I think that Suzanne said this best, but it's just this need for shifting management from our previous view was that command and control was the way we looked at forests, to a resilience-based adaptive management, protecting where feasible and triaging where necessary. Triaging meaning that we're not going to save everything, and we need to figure out what we can save and what we need to accept and move on. And lastly, adaptation only goes so far. Almost all the speakers ended by saying we really need to start reducing greenhouse gases. So the idea is not to discourage people by talking about the horrible things that are happening, but try and encourage people to action. We need to start doing something. So I'm going to try and zero in on some of these topics, one being this question of complexity. In preparing for this, I looked at some older presentations I made, and this is from a presentation that I made over 10 years ago. And you can see it's a paper that was published in 2008. But it looked at the predicted changes from climate change. In 2008, climate change really was just kind of getting to start. But this group of authors identified a whole range of things which are changing and projected to change. And now we've seen over the last few years, they are changing rapidly. And how does that relate to what's going to happen with species? It's complicated, extreme complexity. And I think if you go back and go through, with the exception of the marine impacts, you're going to find examples in those presentations of all of these things. And I think that that's created a major challenge for us as land use managers and biologists and resource scientists. And I think we need to keep in mind that these shifts, the ones that Colin was talking about and I've talked about previously, are not something that's going to happen in a nice, easy manner. But what we're going to see is ecosystem reorganization. Every species has got different tolerances and different capabilities, and they're going to react differently to these changes. As Colin pointed out, these changes are quite complex. And there's going to be lots of things coming in that we haven't seen before, some of which, such as these bark beetles, are not going to be ones we want to see. And we've already seen populations explode and having them react in ways we've never seen them react previously. And the other thing we need to keep in mind is that there's more of a context to this than just climate change. In the talk I gave last year, I spent quite a bit of time talking about the biodiversity crisis. Biodiversity crisis hasn't gone away. And in fact, the report that came out from the IPCC last week had this diagram in it, which talks about the way in which climate change is likely to amplify the biodiversity crisis. And given that we're headed for +3 degrees, which is this chart here, you can see that British Columbia, we're in this 25 to 50% loss of biodiversity. So the more reports come out, the more serious it is and the more need to act. So what I wanted to do is to change pace a bit now and follow up on some of the comments that were made by Mike Flanagan about the role of the jet stream. And I think this is an interesting topic. As he pointed out, the jet stream results from the difference in temperature between the Arctic and the temperate or even tropical regions. And because of amplification, the polar regions are warming much faster than other parts. So therefore, this amplification is decreasing. And what it's doing is slowing down the jet stream and making it much more wavy than it was previously. And this is a driver for a lot of these really extreme events we've seen. And I'm just going to show some examples. Both of these that Mel brought up were tied to changes in the jet stream. This is just a couple of examples. This is what the jet stream looked like in February 2019. Probably don't remember back, but it was an extreme cold period for us. There's Nelson there. And this is what the temperature pattern looked. You can see that the temperature in southeastern BC was somewhere between 10 and 12 degrees below normal, because this cold air had been sucked out of the Arctic, and in fact, it was replaced by warm air, and the Arctic itself was much above normal. And then the year previous to that, we had the opposite effect. In 2018, the jet stream was running very widely this way. We had this, what we thought was a big heat experience in 2018, and we had fairly severe fires in 2018 as well. And we're looking at, again, increases in temperature about 10 degrees above normal. This was a projection for, or the forecast for Nelson during that period. First time I ever saw 40 degrees in the Nelson forecast. But we could look at another one here. We could look at Fort Mac. This is Fort Mac. On those 3 dates, you can see the jet stream has pulled hot, dry air off the southwestern United States. And what was the result? Again, a huge buildup of heat. On this particular day, 2,400 homes burned down. You can see that the fire rating index across Canada was high to extreme during that period. And slowly but surely, eventually this moves on. But the reason that it's moving on slowly is because the jet stream is moving slowly across, and it's got this huge amplification. Now let's come up to 2021. This is the shape of the jet stream during late June when we were getting the heat dome building. And this is the temperature. You'll notice now we've moved up to 20 degrees above normal during the heat dome for southeastern BC, which basically, in combination with the jet stream doing this big wobble, we also have a high pressure system, which is zeroed in on us, and it's holding that warm air right down on the ground. And of course, we know the results of that. This is a thermometer on my back porch during that period, 48 degrees. This is the smoke at 4 Mile Beach during that period. Nelson is down there in the smoke somewhere. And of course, we had the Lytton fire with these pyrocumulus clouds creating their own weather. And this was Lytton. And there's subsequently, over the last couple of months, some scientists have gone through and said, well, what role did climate change have in that event? Well, it would have been a 1 in 1,000 year event, but it was 150 times more likely with climate change. And in a 2-degree warming world, which is what we're headed for by 2050 right now, this will be, last summer will happen every 5 to 10 years. So big changes ahead. And now let's go to November of last year. This is what the jet stream looked like then. It brings in this moisture off the Pacific, and this is Hope, this little star here. So you can see the jet stream is very active. And this is what it looked like in a satellite image, which is keys in on the amount of moisture in the atmosphere. These are the Hawaiian Islands. So this is perfectly what we used to call the old Pineapple Express, where you had this moisture picking up in the Pacific Ocean, and it's brought in to the west coast of North America. This is a satellite image from the next couple days later, Hope being here again. And you can see the way that moisture is concentrated in there. Well, of course, that resulted in severe flooding. If you look at this, this is the amount of precipitation over a 2-day period. You can see these areas here just west of Hope. We're talking about a 0.5 meter of precipitation in 2 days. Of course, there was going to be serious issues. There's subsequently been attribution analysis with that and saying, well, how big a role did climate change play in this? Well, atmospheric rivers like this are not that uncommon. Every 1 in 10 years. The difference was the amount of moisture that was in them. And it was 60% more likely to occur because of climate change. And the 2-day precipitation would have been a 1 in 50 to 100 year event, but it was 50% more likely because of climate change. The extreme stream flow was 2 to 4 times more likely, and that was partly because the way in which the storm occurred was that it began as snow and then turned to rain. So we had rain on snow, which meant that stream flow was even greater than what precipitation itself would have projected. But it's not actually the whole story. It's been billed as a climate change disaster, and most of the stories, including the deaths of these 5 people, have said, oh yeah, it was a very unusual storm. But it wasn't just the storm. When you look at where this landslide came down and killed these 5 people, where did that slide originate? It originated off a logging road. And in fact, further inspection has shown that it was a drainage diversion off that logging road that created this slide. So this is an air photo taken previous to the slide. You can see this fact of the roads and the way it contributed. So was it a climate change disaster, or was it a forest harvesting disaster? Here's another example. This is Grand Forks flooding in 2018. This is downtown Grand Forks here, Highway 3 coming across through town. This is a flooding that took place in 2018. You can see a major portion of the downtown was flooded, as well as these suburbs down here. And it was attributed to high snowpack, rapid snowmelt, spring rains, record peak flow. But when you look upstream, this is the Kettle River watershed, extends a bit above here. And we look at the upper elevations of that. This is a recent Google Earth from the upper elevations. Well, was this just a climate change event, or was it also a logging event? This is another example where you can actually combine climate impacts through a couple of mechanisms. This was a fire that took place in 2003 in Upper Kuskook Creek. You can see it burned the headwaters. There's also been a bit of logging up there, but a significant amount of burning. And it was very intense burning, we got water repellent soils, and then the next summer we had rain, and we had a number of houses destroyed. Highway 3 was closed, and fortunately no one was injured. And now there's ongoing risk. But in this case, again, is it a climate disaster, or is it the fact that we've chosen to build our communities on fans, which are actually flood-prone areas? So what is it? Well, when you think about climate disasters, any disaster, there's two parts to a disaster. One is the hazard itself, and the second is whether you're vulnerable to that hazard. And in this case, the hazards are climate extremes. But as I've shown, there's different things that create vulnerability. One is location. If you're on a floodplain, alluvial fan, an unstable slope, fire-prone forest, you're obviously vulnerable. Inadequate infrastructure increases that vulnerability. Poor road drainage, as we saw in that one case. If you're allowing fuels to build up around your house, inadequate infrastructure in case of flooding, and altered landscapes can also increase vulnerability as forest fire fuel buildup, excessive clear cutting. So the other side of that is survival equals hazard plus resilience. And resilience means trying to erase these things that are creating vulnerability. So climate change mitigation, which is reducing the hazard, in other words, reducing GHGs, is hazard reduction. And climate change adaptation is building resilience. And it's trying to alleviate these kinds of things that create vulnerability. So there's another part to it as well, and that is, where are we going in terms of the future? Well, the really scary part is there are tipping points. We can't just keep carrying on. Some of these have already started. We're losing Greenland ice sheet. Our summer sea ice is diminishing. Alpine glaciers are going. Coral reefs are disappearing. Some of them are potentially started. We're concerned about loss of permafrost. What does it mean in terms of these feedbacks? Well, this is just looking at wildfire in BC. These are the trends over the last century, where you can see up until around 2000, they were decreasing, but now they've started a steep increase. And what does this mean in terms of feedback into the climate system? Well, this is the amount of carbon that was taken up by the forests in BC over the last 30 years. And you can see that there was lots of carbon being taken up, and then all at once in the early 2000s, it dropped off. All this is sequestering. This is great. We're taking carbon out of the atmosphere. But we had the mountain pine beetle impact, which in fact is a feedback from climate change. And that reduced the amount of sequestration because we lost all those trees. And then we've now had more wildfires, which has reduced it even further. And if we add into that the emissions from our harvesting, which is basically forest products that eventually are burned or disused, chucked into landfills, a bit of slash burning, which is yellow. But you can see early on, it wasn't a big deal because forests were still taking up more carbon than we were taking away. But once we got past here, it wasn't so good. And then we can add forest fire, which is more emissions. And all at once, we're all in the negative. So what does this mean in terms of what we report? Well, this is the amount of emissions that British Columbia reports. We don't report our forestry emissions. And when you overlay forestry onto that, you can see it dwarfs it in a high fire year. And if we look at the net emissions from BC, it's actually substantially higher when we're only reporting this number down here. And so you think, well, the climate change models, are they taking that all into account? Well, I just pulled this out of the latest report that came out last week. Additional ecosystem responses to warming are not fully included, such as permafrost thaw, wildfires, and they're likely to increase concentrations with a high confidence, but they're not in the models. So what it means is the models are saying all this stuff is being, in the colored section of these graphs, is being held out of the atmosphere, but in fact, maybe that stuff may be going back into the atmosphere. And weirdly, the models indicate that over the coming decades, they expect the net land sink to keep increasing, partly because plants take up more CO2 in a higher CO2 atmosphere, but they're not accounting for those feedbacks. So we'll see what the next models say in the next 5 years. Who knows? So what can we do? There are things we can do. Wildfire obviously is our biggest issue around here. Ecosystem restoration, shaded field breaks, treating interface fire areas. I'm sure most of you are familiar with these kinds of things, and fire smarting structures or infrastructure in general. It's things we can do about floods, but really we need to get off floodplains is the best answer. It's things we can do about drought, but are we doing them? Smoke is a bit of an issue. Unless we can stop the fires, we're always going to have to deal with smoke. And lastly, there's just loss of ecosystem services. And that comes down to the government management of our forests. What can one person do? Well, I have to say, I'm not sure there's a lot. What we need is collective action. It's too late for the feel-good stuff. We need to stop putting out fossil fuels, and we all need to work at making that happen. And if we want to do something individually, you just need to ask these two questions every time you do something, every time you buy something, every time you do something. And if you can answer positively to those questions, then you're doing your part. So I would say it's we as land managers are going to have to decide how ecosystems respond. Some people I think have got it right, and this isn't somebody I would normally be quoting, I would have to say, but his statement made in 2015 hits it right on the nose, I'd say. And this young girl, it's a crisis. We need to act like it is. And that's the end for me. Thanks.
Thanks, Greg. All right, everybody. How are we doing? That was great. I picked up some extra bits in your summary of the talks that I think gelled for me in a way that they didn't before. Thanks for that review. Thanks also for your additional insight and all of your many years of work and and sober assessment of what we are dealing with. What we're going to do is move on to questions. We have just over 5 minutes or so. It's possible we can stay just a little bit later if need be, but we'll see how we're going. So just a recap, type your questions into the Q&A. I'm going to relay those in order of upvote. If you see a question that you would like to see the answer to, hit the thumbs up on there. Nicole, I see that somebody has their hand up. If you could communicate with them and come up with a bit of a plan there and let me know, that'd be great. And I will start, Greg, by relaying questions to you. Feel free to open your Q&A if you would like to follow along. So the first question comes from Manuela. Thanks for the presentation. Please be careful when you use forest harvesting as a catchphrase for causal effect for mudslides. The initiation mechanisms are site-specific, and attributing to the forest harvesting is a misconception often heard in the news as well. So I guess that was a comment, not a question.
Yeah, I could respond to that. That's a very valid point. It's you're doing a quick presentation, and you got to make it quick and easy. I would argue that building forest roads is part of forest harvesting. And yes, removing trees may not be causing it, but the way in which we do forest harvesting definitely includes roads. And in this particular case, it was poor drainage control.
Okay, thanks. Okay, so what do you see as being the main reasons Canada continues to fall short on our climate commitments?
Lack of will on the part of our government. They say one thing and do something else. Obviously, there's certain parts of the country, Alberta and Newfoundland in particular, who still depend heavily on fossil fuel as a source of government revenue, and therefore they consider their economic well-being more important than the fate of the earth. What can I say? Until people stop approaching this as a personal economic issue and start looking at it as a survival issue, our commitments are going to fall short.
Okay, thanks, Greg. Are there any other questions? We've got some time, and Greg has a lot of knowledge, so feel free to take advantage and ask your questions or share your comments. Okay. It sounds like we're satiated in one way or another. I'm going to say we don't have any more questions, Greg. Do you have any comments before I move on to conclusions? Oh, we're frozen perhaps. Or you were frozen. No, you're just not responding.
Sorry. I noticed there's one more question there. I was
okay,
looking
great.
at that.
Thanks.
I can respond to that. Yeah, I presume by microbursts you're meaning wind events. Yeah, definitely. But generally they're small in comparison to what we're losing with fire, but definitely they can be.
Okay, so I'm just going to read it aloud for the sake of the recording. How are the microbursts related to the loss of forest cover was the question. Great, thanks. Okay, sounds good. Nicole, oh, okay, we have a question from Martin. Here we go. To what extent will population decline due to distribution cause a reduction in emissions? Do you have any comment on that and the potential for that to reduce eventual temperature rise?
I presume by population you mean human population. Well, I think we've had a good look at that over the COVID pandemic. We've had a significant population decrease. Emissions went down as we shut down to try and fight off COVID. But in the end, they've risen right back up to where they were before. In fact, they've continued to increase. But eventually, yes, you know, as climate change, the impacts of climate change increase, the human population may go down, and eventually, probably there's going to be huge economic impacts and emissions may drop off. But the fact is that we need to go to zero. And in some ways, if technology decreases, we may in fact begin to increase. So it's really difficult to look at that prediction. It might be worth looking at the latest projection, the social pathways that are in the IPCC report. I think one of those actually looks at the potential for significant population decrease. It's difficult to predict because it depends on what other things change.
Okay, great, thanks. Question from Tracy. Any ideas on how to move the needle regarding political will?
If I had the answer to that, I think just continued pressure. As I said, elections are opportunities. We need to take advantage of them. Unfortunately, the last couple elections, our choices have not been great.
Okay, so actually Laura has a comment related in the chat that people might want to look at. So she says one of the best things to do for helping climate action is join with others and not give up in despair. Look for people working in your community. And then she provides an email address if people want to connect with her for some resources and motivation in that regard. As Greg said, we need everyone, she says. So I'm going to move on. There's a question here from Mike. Given world events seem to override greenhouse gas reduction efforts, what's your view on carbon capture efforts?
Well, almost all the IPCC projections that show us actually staying below 2 degrees or especially 1.5 degrees require the removal of eventual removal of carbon from the atmosphere. My personal view on it is that it's pie in the sky. We have technology that can remove carbon, but to scale it up to the scale we need is highly unlikely, and it's also very expensive and energy consuming. It makes much more sense from an economic and a reality to prevent emissions, not to think about removing them later.
Okay, thanks. Question from Tyne, may not, you might not be able to answer, but She's just curious, what do you find is the most important avenue for pressure by citizens to force political change? I guess you kind of answered this already.
Yeah, I would just say I would echo Laura's comments that working with other people in large groups could be through 50.org. It could be the climate lobby group. There's lots of organizations out there, and I think working in those groups is definitely a good idea. Even Extinction Rebellion, if you want to take a more radical approach.
Okay, great. Thanks, Greg. Okay, we don't have, oh, here we go. Great. So Tracy, she asks, thanks so much for all the information. Oh, she's just commenting. Thanks for your time, and your efforts are appreciated. Yeah, I'm sure we can all echo Tracy there. Okay, last call for questions. Hearing and seeing none. Okay, thanks, Greg. I'll move on to some conclusions. As I do, I'm sure there will be some comments in the chat that you want to catch. Nicole, if you could pull up my slide, please. Thanks very much. So this is the finale talk. This is the point at which I usually start to talk about the talk to come, but I won't be doing that right now. Instead, I would like to, of course, echo our thank yous to our sponsors, so the Columbia Basin Trust, the donations from all of you, your continued support in sharing these talks. I know they are doomy, and we've received some emails in that regard with some concern there. But of course, we're just presenting the research to the unfiltered research, which I think we all really need to hear. And I think it's important to get that message out there and that people understand what's happening. And I really appreciate your support sharing this series out with your networks. It'll be available on the event webpage, easy click, and this talk will be up by next week. What else would I like to say at this point in time? I think that's it for now. We will follow up with a little bit of information via email for all registrants, perhaps some more resources for you. If you are listening to the recording and you're curious to know what resources are being sent out, you can send me an email and I can share those with you. And yeah, I just want to say thanks. I think it's been a successful series, and I'm really grateful to everybody who's participated. Maybe I will just, Nicole, if you go to the next slide, we'll just end on this. So if you are looking for some motivation to act, to push for some collective action, as Greg suggests, this talk I found to be fairly motivating, and was suggested by one of our speakers, Colin Mahoney. It's short, and you can easily Google it, and it might help to give a little bit of motivation to keep pushing for change. Thanks very much, everyone. If you have any questions at all, then send us an email. Bye.